Alright, number 3, we want to find f of g of x and g of f of x and then the domain of each. As you start out with these composition of functions and finding domain, you want to find the domain of each of the functions first. Okay, so this is number 3. You want to find f of x first. Okay, so we have x plus 1. And then you want to find g of x as well. G of x, that function is x squared or 4x squared minus 3x minus 1. Okay, so in f of x there are no fractions with x in the bottom, no square roots, and no logarithm. So your domain, the domain of f is negative infinity to positive infinity or all real. And then same thing for g, no fractions with x in the bottom, no square roots, and no logarithms. So the domain of g is also negative infinity to positive infinity or all real numbers. It's important to figure this out because if there are restrictions, those restrictions have to be carried over whenever you do f of g or g of f. So this first time we want to find f of g of x. Okay, this means you're going to start with the f equation, and everywhere you have an x, you're going to replace x with the whole g equation. Okay, so I would start off with the f equation. Okay, the f equation is x plus 1. So instead of x, I'm going to write blank plus 1 because I'm replacing x with something else. I'm replacing x with the whole g of x equation. Normally I would plug that in parentheses. You don't really need it because x is not being multiplied or squared. But just for the sake of continuity, we'll do it. So we're going to do 4x squared minus 3x minus 1. And then from here you can drop the parentheses because you don't have to solve anything. So this is just equal to 4x squared minus 3x minus 1. Bring down the plus 1, and the minus 1 plus 1 will cancel. So we're just left with 4x squared minus 3x. So this is what f of g of x is equal to. Okay, and then when we find the domain of this function, again, no square root, no log, no fraction with x in the bottom, so the domain is still negative infinity to positive infinity. Now, since we plugged in g of x, if we had any restrictions with g, those restrictions would come with me because I'm still plugging in x value to g and then plugging that into f. So if anything would have made, anything was left out from here, I would have to carry that on to the domain here. Okay, so that's f of g. Let's go ahead and plug that in. 4x squared minus 3x. Okay, so now the domain is negative infinity to positive infinity. Alright, and now we're going to find g of f of x. So, same concept. This time we're going to be plugging in f equation to g. So, g of f of x. We're going to start with the g equation, which is 4x squared. So 4 times something squared, we're replacing x. And then minus 3 times x this is the g equation. I've left out the x's. The x's are going to be replaced with the f of x equation. I didn't rewrite it, but it's equal to g parentheses f of x. Okay, that's the translation. So f is x plus 1, so 4 times x plus 1 minus 3 times x plus 1, and then minus 1. Alright, here we have to FOIL. I'm going to do the shortcut. I'm just going to FOIL x plus 1 times x plus 1. Bring down the 4. I'll do that one last. I will get, you square the first term, x squared, multiply the 2 in the middle and double. So that's 1x, double it, it would be 2x. And then square the last term. So 1 squared is just 1, positive 1. And so I've squared this, and then distribute the negative 3. So minus 3x minus 3, and then bring down the minus 1. Here I will now distribute the 4 throughout parentheses, and I will combine like terms as well. So this will give me 4x squared, and then plus 8x, and then plus 4, minus 3x, and then minus 4. And then we're going to cancel out or combine like terms. So the plus 4, the minus 4 will go to 0. We will combine the 8x and the negative 3x. So this will give us 4x squared plus 5x. So this is our function here. And then again, when we find the domain, there are no square roots, no fractions, no no logs. So domain is negative infinity to positive infinity. So g of f of x is 4x squared plus 5x. And domain was negative infinity to positive infinity.